Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture number 6 of the course of Computer Networks and Internet Networking. My name is Engineer Jaffar Ali and I am instructor for this course. So today is our sixth lecture and this is the first part of this lecture sixth. Uh, Today's topic will be about RARP, that is Reverse Address Resolution Protocol. But before going into that, let's start with the recapitulation of the previous lecture, that was lecture number 5, both part A and part B. In the lecture number 5, part A, we have discussed about two of the main protocols that was in transport layer. The first one was TCP, that is Transmission Control Protocol, and the second one was SCTP, that is Stream Control Transmission Protocol. And we discussed about the different dimensions about how they work and how they are implemented in different kind of scenarios in terms of transport layer. After that, in the lecture number 5, part B, we started the layers of network layer and protocols. The first protocol that we discussed was basically ARP, that was Resolution Protocol. And we saw that if you have a given IP address and you want to find a MAC of an given device or a destination point or destination device, you can do that by using ARP. And we discussed that how these ARP and all these four cases that were included in this ARP. So that was the brief discussion about the previous lecture, lecture number 5. So in today's lecture, we are going towards the other thing around, that is RARP, Reverse Address Resolution Protocol. And this is the same concept that we discussed in ARP, but it is in the reverse form, and it is also used in network layer actually. I told you, I promised you that I will be teaching you much about the protocols in the network layer. So that's another protocol that is applied on the network layer. You can apply this as in the network layer as well. So let's see what's RARP. So the RARP is basically stands for Reverse Address Resolution Protocol. Now consider a scenario where you have just booted your system, or you are using the system very much for the first time, or you have just rebooted your whole system. You can say you have done the factory reset. So the only thing that that machine would have at the time of their switching on, the only thing that it will carry will is basically the MAC address. Instead of any other thing, it will only carry the MAC address at that time. So how the device will know about its IP address or any other information, the subnet masking or anything? But first thing is basically the IP. We are not talking about any other information. We are talking just about the IP information. How would that device will know that my IP is basically 192 or anything like that? So the first thing it need to have is basically an IP address, and for that IP address, it will initiate RARP process. And let's see that what is this RARP process. And it is a diskless machine. If you see that it is a kind of algorithm where you can find the IP address from the physical address or the MAC address. As simple as that. I have defined the RARP protocol in very understandable words, that RARP is basically the reverse process in as compared to the ARP. In ARP, you actually find the MAC address using a IP given IP address using different cases or different methodology. We have discussed that about the unicast and the broadcast mechanism in the ARP as well. Now take the whole scenario and just reverse it. If you are given with the IP address, a MAC address, and you are asked to find the IP address of that MAC address, you can do that by using RARP. So a diskless machine is usually booted by a ROM, and it cannot include the IP address. So you have to find the IP address actually, and if you are given with the MAC address, and this MAC address you can from where you can achieve it can be achieved using any means. And IP address are assigned by the network administrator, and to obtain its logical address by the physical address you can use RARP. It means that if you do not have a logical address, or you can say the IP, and you want to find the IP of a system by given its physical address, you can say the MAC address that is given to you. So how can you find the IP address by using the MAC address? You can find that by using RARP protocol. Let's see the operation of RARP protocol, that how this RARP actually works. So let's see, I have my physical address and it is mentioned over here, and I am looking for my IP. So how can you find the IP address? Basically, this is your host and this is your RARP server. So you actually broadcast your message to the server, towards the server, and this request message will be broadcasted. I have already told you that only the reply will be unicast, but the message or request will be broadcasted. So the first step is that you have to broadcast your request. You ask every user in the network that please provide me my IP address, so that the response from the RARP server will be unicast. It will receive the RARP request message, and it will look into its own database, and it will provide you your IP address by using a unicast a propagation or methodology of transmission. All these other nodes that will be connected to the network will discard this request, because they will not have any interest in providing you your IP address until and unless they are some thing that know you personally. So if they do not know you personally, they won't be able, or they won't provide you your IP address. Only the RARP server will respond back by telling you that this is your IP address. So this is the same operation. You know that this RARP request packets are broadcasted, and the reply is unicast. You see that if you are requesting, I will repeat again, if you are requesting, so you have to broadcast your request. You see that this packet is being broadcasted among all the users of the server, or the internet, or any network, and the reply will be only the unicast. This reply won't be going towards this destination or this destination or this destination. These systems will not be receiving this reply message. Only this host that generated or originated, this is basically the technical terms you have to use. The only those systems that originated the packet or the request, that will receive the reply message using the unicast methodology by RARP server. So let's see the format of that packet, that how does this format of RARP is actually going to be. So the format of RARP packet is the same as the ARP packet, except that there are the operation field. You can use three. There were in the first ARP, if you remember, we were having two options: one for the request message of ARP, and two for the reply message of ARP. Now you are extracting that field, and instead of using 1 and 2, you are using actually 3 and 4. The operation field, let me show you the operation field. This, you can see that the operation field, this is your operation field. The in the ARP you are using A1 and 2 for the request and reply respectively. But now in RARP, if you are getting a packet and you are seeing the 3 over here, so understand that this is basically the RARP request message, or request packet. And if you are getting a 4 over here, you can observe that, you can understand that this packet is basically the RARP reply packet. So by using this operation tool or operation field, you can understand that which kind of protocol it is using, and which type of packet it is. Is it a request packet, or is it a reply packet? and all the other fields, you can see that all the other fields are remain the same. Most of the fields are remain the same. There are no much difference, but the only small difference and the important difference was the operation field. Using Instead of using 1 and 2, you are using actually 3 and 4. So this was the format of this packet. And now how can you encapsulate this RARP packet? So as ARP, if you remember that ARP was encapsulated in the data packet. Similarly, this RARP packet or request packet or reply packet, this will also be encapsulated in the data field as well. You can see that this is the complete format of the packet, and you do not have to indulge this encapsulation or this information of RARP packet in any of other fields. You just have to indulge them or merge them in that data field actually. So it is highlighted over here. You have to encapsulate your RARP packet in this data field. But to encapsulate that, the first thing that you should be keeping in mind that the size of the RARP packet should not be greater than the amount of location or memory you are actually going to have in the data field. If the data field, let's say, is comprised of, let's say, 8 bytes, and you are having a data of, let's say, 7 bytes, so you have to keep in mind that you have to prepare your RARP packet in less than 1 byte actually, because you see that this is the rule for encapsulation, that the combined data cannot exceed the size of the original field. So if you have a field of, let's say, 8 bytes and there are 7 bytes of data, so you have to encapsulate your RARP packet in less than 1 byte. It means that you have to ignore most of these scenarios. You have to ignore most of these information. You cannot indulge more information, but you can indulge them important information in that packet. But you should also keep in mind that sometimes this won't work if you are reducing your size actually in very less way. So it is possible, it is highly probable that your RPR, this request or reply message, won't be delivered as completely reliable with reliability, because you see that you have reduced the size and you have ignored very much of the information. So it might take this as a irregular packet or corrupted packet, and it might the packet might be discarded or asked to resend from the receiver side. So you have to keep in mind that the size of the RPIV packet should not be less than any given certain amount of data. Now there are some other solutions through which you can use this RPRV. So the first thing is, let's say when you are using a diskless computer and you rebooted it, you have rebooted it. So it will need some information, some basic guidelines in addition to its IP address. So the basic information that it have to be there should be the subnet mask, the IP of the router, and the IP address of the name server. So you have to keep in mind that this information is also very much important when you boot a diskless computer. There is no memory, so you have to have some information about these things. So RARP cannot provide this extra information. For this extra information, you have to use boot TP, DHCP, or instead of these RARP. Instead of using this RARP, you have to use some other protocols, because RARP is not providing you the whole information. This is just providing you, if you are using ARP, it is just providing you a MAC address given that you have provided its IP address. So you see, this is just two things. It is not carrying any information about the IP of the router, the subnet mask, or the name of the server. So similarly in RARP, you cannot have all these information, because it might be take you as illegal packet, or you can say a corrupted packet. So if you are using the system for the very first time, or you have resetted or factory default resetted your system, so you have some kind of backup plan. And if you do not have any backup plan or any image file, For that, I will also teach you in class that how you can make a backup file of your router configuration. This is basically very common thing, and I hope all of you must know it. But if you haven't have any idea about these things, please ask me in the class. I will, if you ask me in the class, just ask me the question. I will provide you a bonus mark if you just ask me this in the class. So for any other information that you want to have on your server, on your system, you can have any other protocols that can include that dynamic host protocol, or you can say bootp protocol. This bootp protocol is basically stands for bootstrap protocol, and it is a computer networking protocol, and it is mostly used when in a scenario where you have to find the IP address automatically. It will assign automatically IP address to your device, to your network device, and it will take the IP address basically from a configuration server. So there should be have some server involved in that process as well. Now coming towards this DHCP, this is basically dynamic host configuration protocol, and it also provides you the same services. Basically, it assigns the IP dynamically and using a server configuration. So you have same the property that you have to need some server configuration server that will be having the information about the all the IP's address or the pool of the IP address. So that is where you can use these two protocols to have the other information, that is the subnet mask, the IP address of the router, or the IP address of any name server. There are many other protocols that you can use to gather this information when you reset a system or you use the system for the very first time. So this information will be helping you out a lot of times, and if you don't have this information, please go and find this information for the very first time. After that, you can use RARP packet, RARP procedures, and these protocols ARP and RARP in your coming time. But for the initial time, you have to have some basic information, and for that basic information, you have to follow this bootp and DHCP protocols. So that's all for the first part of this lecture number 6. I will be seeing you in the second part with some other protocols of network layer, as I've already promised you. So the other protocols that I will be teaching you in this lecture part B will be basically ICMP, and these are very important protocols and very basic as well. So you have to have some knowledge about these protocols as well. So IGMP and ICMP, these are the two protocols, and these are very much famous and very much basic, and you will have very much detailed idea of these protocols in the coming lecture. So if you have any questions regarding this RARP packet, please do not hesitate to ask. The more you ask, the more you learn. I'll see you in the second part. Thank you very much. Allah Hafiz.